Alrighty, everybody settled in? We have our timer running, so good morning, everyone. Welcome to this ultimate battle between Spring Boot and Quarkus. We're gonna create some music, hopefully, today, so it's gonna be fun, at least. So my name is JAGO de VRIEDE, and I really like doing stuff with musical instruments. I play an instrument myself, but in this case, I created a acoustic guitar, automated it. So I like music, and this is BERWOUT.
Yeah, my name is BERWOUT ROBLES. This is me a few years ago, also making music on stage with a keyboard. I was actually here 5 years ago in this very room doing the same thing as well. Yeah, I've been working with Spring Boot for a long time, so I'm representing the Spring Boot side of this battle. Working for Spring Boot for 7 years now, I think, which is longer than Quarkus exists. So
yeah, Quarkus is around four years or so. I've been working with the beta versions of Quarkus, so and using Quarkus in production as well. So, but as you might have seen, he got a cake, and the reason why he got a cake, because it is his birthday, his actual birthday. So, can we get a hip hip hooray on 3? 1, 2, 3. Hip hip hooray! Okay.
You'll cheer louder for Spring, I hope.
Anyway, what are we going to build?
We're going to build a simple little application that basically takes all the things you like from your enterprise software, but presents them in a more musical theme. So we have a conductor that's going to basically tell the drummer what instrument to play, and he's going to give a beat as well. He's going to count 1, 2, 3, 4, 5, 6, 7, 8. And then we have several drummer applications that are going to ask, what's my instrument that I have to play? And then they're going to play on beat, hopefully. And yeah, it's kind of a wrapper around the things we always do in enterprise applications, like data access, WebSockets, REST clients, all that sort of stuff. So it's all in there. And then we're going to contrast and compare those different solutions between Spring Boot and Quarkus. And then in the end, it's a popularity battle, because that's the way to decide what is the ultimate framework. So you're going to have a vote in that. This is the beat that we're going to try to create. It's relatively simple. There's going to be one drummer that's going to be playing the hi-hat, which is on top. He's going to play on every beat. Then there's a kick drum in the middle. And then there's a like bass-heavy drum at the bottom. There are 3 individual applications playing on the same beat, basically, and the conductor is going to keep time. All right, let's get started then with the comparison of the frameworks. In order to get started for Spring, you just go to start.spring.io. Who here has used start.spring.io before? Ah, it's my crowd.
We'll see, we'll see.
We like it in dark mode, because then you don't get so much blinded. And then you basically select which build tool you want to use, which language you want to use. You select the Spring Boot version that you want to use, and some dependencies. And in this case, we're going to build the Conductor application. And for that, we're going to need Spring Web to create the REST endpoint, and Spring Websockets to create the server endpoint for the WebSocket. And that's it. Over to what you get. You hit download, you get a nice zip file, and then you unpack it, and you get this. You get your Spring application with a small little README, and the Conductor application that starts up your web application. How does it look from Quarkus side of things?
Well, Quarkus, of course, you don't go to the Spring site, but to the Quarkus.io site. And there you can do the same thing. Create a Quarkus application just like the Spring application. Choose which build tool you want, which Java version you want, which dependencies you want. And let me just try this also. Who has used the Quarkus starter before? There's some people. It's not overwhelmingly big, but all right. So in this case, we're going to use, of course, Java 21. And we're going to do the REST easy web service. And we're going to do WebSockets, of course. And I thought we're going to do something with scheduling. So I will be using Quartz. What are you going to use?
Yeah, we actually get that for free in our starter, because Spring is batteries included.
Free but heavy. Yeah, right. All right. We get, of course, the same thing, a zip file containing a README, which instructs you how to set the application up. And we get some nice examples. If you want, you can click that off if you don't want that. But we got a example greeting resource and a web service of a WebSocket server here as well.
Some nice code to immediately delete.
Yeah, but you can also think it of.
All right, so here's how the popularity contest is going to work. For every round, basically, after the round, if you see this screen, you're going to raise either your open hand for Spring Boot or your fist for Quarkus. And in the end, we're going to be the judge of what the result was.
And if you think it's even, which is most likely, don't raise your hands. Also fine if you're sleeping. So anyhow, who thinks Quarkus is the winner here? And who thinks Spring?
Hands up for Spring. I don't know how we deserve that, but
Yeah,
we won anyway.
how does that work? It's exactly the same.
All right.
So we're going to create a REST endpoint then. There's this part of the conductor where the drummer is going to ask for his instrument, and the conductor is going to give back which instrument is going to play. So we got our greeting resource, which is quite useful because now the greeting resource can be renamed to a instrument resource. And well, there's an example in here that's going to return a string. We don't want a string, we want a instrument to be returned. And that is coming from a all instruments array list where the hi-hat is the kick and the flam. And we're just going to cycle through those instruments. So if a fourth drummer would come, then the loop will start all over again. And just going to return it as a string. That's it.
From the Spring side of things, yeah, if you squint, you won't even notice the change. The thing is, we have a few different annotations than the Quarkus side has. We have @REST controller for the controller, and then we have @request mapping and @get mapping, but all the Java logic is the same, and it looks very similar.
Yeah.
But we had to create our own class, yeah, you could rename. All right.
So, Quarkus versus Spring. Okay.
I would say pretty much even.
Yeah.
All right, then we're going to look at the WebSockets. So how do we create WebSockets from the server side in this case? So it's this side. The conductor is going to have a WebSocket that people can connect to, and then it's going to pass the beat 1, 2, 3, 4, 5, 6, 7, 8 over that WebSocket. In Spring, it looks like this. We extend a text WebSocket handler. Actually, most examples will have you do stomp.js, which is a common WebSocket framework or WebSocket standard. We just wanted something very simple in this case, so we have a text WebSocket handler. You can then override some of the methods from the text WebSocket handler. So in this case, we have the after connection established. And if the connection is established, we put that WebSocket session inside a list of sessions at the top. And then we have a broadcast function that allows us for every session in this list to broadcast a message to this session. Then we're going to need to configure this WebSocket to accept incoming connections. So for that, we have the WebSocket configurer, which we just create a class with an annotation @configuration to have the bean. And then we implement the WebSocket configurer, where we override the register WebSocket handler method. And we say, hey, handler, please register on this /beat that we have this beat WebSocket that we would like people to be able to connect to.
All right, and with the Quarkus side of things, we kind of do the same thing like a REST endpoint, except it's not a JAGO endpoint, it's now a WebSocket. So we can use the annotation @server endpoint. We can just use a path annotation with a path parameter in there, because there are multiple drummers connecting to the conductor. So those drummers have a name when they come in. So
yeah, that's one thing that was a little bit interesting from the way we do the registry.addHandler. We don't actually get any path mapping there. It's because we promote passing those parameters inside the WebSocket session.
Yeah, right. Anyhow, so we have those path parameters, but this is our example. So we're going to rename this as well to the beat WebSocket. We have a on open, on close, and on error by default. I think Spring has the same things, but he chose the easy route. So what I'm going to do is implement those as well. It uses the same broadcast functionality, so a concurrent hash map with all the sessions in there. But instead of using the session ID as a key, we're just going to use the name of the drummer as a key for the session. Not really a great idea, but it works. And of course, if the Websocket Client closes the connections, then we're going to remove it. And even if there's an error, we're going to remove it as well. So, but same logic here. So who thinks Quarkus wins, or
Spring wins.
I still see some Spring hands, but there are.
Yeah, I have to be honest. I like the Quarkus side on this one too.
Yeah.
So it's
So the conductor needs to send out the beats to the drummers, and we're going to do that every 15 seconds. We're going to play a total of 32 beats, and if you play 32 beats, it's around 12, 13 seconds or so. So we get a nice pause of 2 seconds between those musical scores.
and that's so you don't go completely nuts listening to this while you're developing this.
No, only 90% nuts. So let's implement this. So we're going to create a conductor class. This is our first actual bean what we're going to create ourselves. So we're going to create an application code bean. It's and we're going to define a BPM, and we're going to do some time magic. So we need to divide some milliseconds to minutes. And then we're going to use the scheduled annotation on a non-private method. This could be a default method if you want, but a public method works as well. And then we can add the scheduled annotation, nothing more, and we can say every 15 seconds this method will be called. And within that method, we're gonna keep track of the number of beats played, and we're gonna try and calculate when the next beat should be played, and then we're gonna wait for that time to arrive. And when there are 30 beats played in total, then we're done with the loop. And if it's time to play, then we broadcast it to the Websocket server, and then hopefully the drummers will listen to the conductor. And if you want to run this application, if you're using IntelliJ, the full version, then it will come out of the box. You can just use the run button. But if you use the community edition, then there is a plugin for Quarkus, and then we get the same functionality. And if we would run this, then we're going to start up Maven, because Quarkus does some build argumentation in the build step. So it needs to call the actual Maven plugin. So it's actually calling Maven. And that is starting up the application. That's why it's taking about 12 seconds to start up the application. The application itself started up within 2 seconds, but there was a whole build step before that. So what about Spring then?
For Spring, we're going to do the same thing. We're going to implement the conductor, and then we have this enable scheduling annotation, and we put the same annotation almost, an scheduled above the method that we want to schedule. We put a fixed rate, and then we actually have a typed variable of seconds, whereas you use a string. I personally prefer the typed variable. Then it looks basically the same. We're going to play up to 8 beats. That's why the module 8 is in there. I'm going to play 32 beats at a time. Implementation is, it's all plain Java, so it's pretty much the same. Then when we run, we get a little bit faster. It's 6 times faster. So yeah, big advantage to the dev side of things, I think. What did you like most?
So for the scheduling, ooh, says hands down.
I think I won on the startup time there.
Yeah, on the startup time, I'm not going to ask anyway. So anyhow.
All right, then we're going to take the drummer's REST client. So it's going to ask, hey, what is the instrument that you want me to play? And it's going to get back an answer, basically a REST client call you do in pretty much every enterprise application everywhere. We're going to build a separate application for that part, because this is the drummer. For the drummer, we need a few more things, because we actually want to retrieve some things from the database as well. So we have a PostgreSQL driver in there and a Spring Data JPA. And otherwise, it looks pretty much the same. You notice that maybe WebSocket does both the client and server side of things on the Spring side. We have this annotation @post construct, which will run after our application is initialized, but before it's ready. So it will run on startup. And then we have this @value annotation, which we can use to get configuration properties from our application.properties file in the resources folder, where we're going to store the URI that we want to call. And then we have the new Spring 6 REST client, which is the synchronous version of the web client that we got in Spring 5. It's a web client. It's really not that interesting. It does a get call to our instrument URI, and then retrieves the response we get as a string. And that's which instrument we're going to play. So if you look in the application of properties, you can see here that we set up the instrument URI, We wanted to run multiple drummers at the same time, so that's why we set the server port to 0, so it chooses a random port to start up on. And then in the init, we're going to fetch our instrument from the drummer, and then for now we're just going to log it, because the data storage comes in the next section.
So for the Quarkus side, again, we need to create a new application. And in this case, we can create a Websocket Client, because we don't want WebSocket service. Why do we want WebSocket service in our client?
Batteries included.
Yeah, batteries included, heavy batteries. And then again, we're also gonna need something with the database. So we're gonna need Hibernate, and we're gonna use Panache. Panache is like the same as Spring Data, so it offers some free stuff there as well. Then we're going to use a REST client, and of course we need the database as Postgres as well. So here we're going to create our drummer. We don't have the add post construct annotation because Quarkus will remove any beans that aren't being called or aren't being used in your application. So if the bean is only being used as startup logic, it's not going to work.
Did you learn about this the hard way?
Not going to comment on that. Anyhow, you can just use a startup event that's going to be sent out in the application with add observes. And then we're going to listen to the startup event, and that's now we have the same logic as post construct. And we're going to create a REST client. A REST client looks exactly the same as your REST server. So your REST server can actually implement this interface. Only difference is that this interface has a register REST client on top of it, because it's a REST client. So the implementation of this REST client will be generated for you. But we can't use the really nice short Conductor API string because we are using a REST client, so we have to configure that via Quarkus. So the Quarkus REST client Conductor API, and that's why we set the URI for the REST client. And it's going to be a bean, so we're going to give it a scope, a singleton scope. That's fine for now. So then we're going to use this REST client in our drummer. But if we're just going to use the add inject, then it won't inject the actual REST client because that holds the additional code that's been created. So we're going to inject a add REST client. And that way Quarkus knows that this is a REST client and that it needs more code for it. And then do the same thing, just log it to the console. So, who think Quarkus won this round, or Spring? 50-50, and still a lot of people undecided, so okay. So, database access then. So the drummer is gonna need to know on which beat it's gonna play, and that is called a drum pattern, and we're gonna retrieve this drum pattern from our database. So of course we need to configure our database. We need to set the data source, DBC URL, a database username and password, that kind of stuff. And we're gonna do a drop and create only with a dev profile. So if you can see here, there's a add dev. That means this property will only be valid for your dev profile. You don't want to drop and create your database in production. And I didn't find that out the hard way. So. And then we're going to create a drum pattern. It's just a JPA entity with a generated ID value with a name and a pattern, just as simple as it is. And then we're going to implement a repository. This repository will implement the Panache repository. It's a base class that holds a lot of logic, like a persist, like a find, and you can actually call queries and that kind of stuff. So we can just call the find, and then we give it a query with name, and then we're interested in the first result, and that is going to be returned. And then again, just going to inject that repository and just going to use it and log it out to the console as well. We're also going to need some drum patterns in our database. So if we create a import.sql, Hibernate will automatically pick that up. You can turn it off if you want, and that is going to create our drum patterns in the initial database. So you can see that the hi-hat plays on every beat, and the kick on the first and the fourth note, and so on. And this will represent this core.
From the Spring side of things, yeah, we give it the same. We give it the data source URL. We add a few annotations actually. The Spring SQL init mode always. That's to get the import SQL in our database. We add the deferred data source initialization, which has to do with the fact that the Spring beans need to be loaded into memory before you start to do these database operations. So you have to wait with the data source initialization till after startup. And then we have the DDL auto set to update. That actually has to do with the fact that I could not get it to work properly with create and drop with the deferred data initialization. So it would actually try to insert the records before the table existed. With update, I got there fine, but it is something that was a little annoying. It's probably my fault. This looks exactly the same, basically, because we're using the same sort of language there. And then we have something nice, which Quarkus doesn't have. We have the JPA repository from Spring JPA. And there you can actually just extend this repository. It will give you all this functionality that you have, like the create, read, update, delete, all that sort of stuff. And then you can also have a DSL, which we can use, which means that you can write this method name, and the method name is enough to actually implement this code. We don't have to implement it ourselves. So you just write find by name, and it will generate the function for you. Then we do the same thing. We inject the pattern repository into our drummer, and then after retrieving the instrument, we will go and find it by name. I'm using @autowired here. That's bad practice, guys. Use constructor injection. So this is just for brevity of the example, but use constructor injection everywhere. And then, yeah, we have the same import.sql. One annoying thing, or yeah, maybe annoying with interoperability, was that because of the way the casing was spread out, Spring made it into drum underscore pattern from our drum pattern entity, whereas Quarkus made it into...
it would just do a drum pattern concatenated.
So we actually got a difference there in the table creation.
So if you want to avoid that, you could also say a table annotation on your entity and actually define the table, which is a good practice, and not let Hibernate do stuff for you by default.
All right, which side did you like? Lots of points for the Spring. I'm wondering, are those same hands people that really like that DSL and use that DSL often? Could you put your hand up for that? Oh, that's interesting to me. All right. Nice.
Alrighty, WebSocket clients then. So the drummer is going to listen to what the conductor is going to say. So hopefully they will all be in sync. And the drummer will get a 1 through 8 in text format.
On the Spring side of things, it looks like this. So you have our musician, which has a file of things to play, and then he retrieves the pattern from the database, and he has his instrument to play. And then basically, we're going to take the list of files that's in our resources, and we're going to find the file that corresponds to our instrument, and then we're going to load that to play. And then we have a text WebSocket handler like we had on the server side, but this time for the client side. And then we register that when a text message comes in this case, I'm just saying I got a beat from the server side. But here we are actually going to register this musician at the bottom with the new standard WebSocket client, and we execute and we register this musician as the text WebSocket handler for this WebSocket, so that when a beat comes in, we're going to do things. And the things we're going to do, it looks a little complicated. It's not really not that bad. We're going to look at basically which pattern we have, and if there is an X in that pattern, we're going to play. And for that, we're going to try and open the audio file that we just loaded and start the audio file at the beginning and then play. And then, yeah, if anything goes wrong, we throw an exception. But that's how we handle our text messages. So a beat comes in, and it starts playing the audio file if there is an X present for that beat.
All right. Then the Quarkus side. Well, we have our drummer, and we're going to make that drummer a REST of a WebSocket client. So we're going to say add client endpoint. And if we add the client endpoint annotation, we can actually say to the container, okay, we're going to connect the WebSocket to our client, and the client is this, and on that specific URL. So that URL is defined on top of there. And then we can have a method with a add-on-message that's going to log that string message to the console. So just got a beat, and that's it. So if you run this, we got a lot of beats. And then we're going to use the exact same thing like the Spring side. So we're going to create a musician. It's going to have a file. It's exactly the same. It's copy-pasted. Also, the play function is copy-pasted. And anyway, guys, if you want to play music or any audio, don't use this because it's not closing anything. So it has a nice memory leak. So it's fun if you let it run for a few hours. And after a while, we can just say musician.play, and then it's going to play the actual beat. So for this round, the WebSockets. I see a few Quarkus.
Yeah, but it's pretty even, right?
Pretty even, a few Quarkus and a few Spring. But alrighty, let's see if the demo gods work today. Just going to show you the Quarkus side because, well, the Spring side is roughly the same. So. What I've done here is I started up the Conductor application. Conductor is running, and now I'm going to switch to the drummer. And we're going to have 3 drummers here. And let me see if I can zoom in here. Alrighty. So I already packaged my application, and I can override the player name, which is usually in the application.properties, with just a command line argument. So I can start up the first drummer, and let's make him me, and just run the application. Well, now you don't have to wait for the entire Maven plugin to run because we already compiled it. So you can hear the drum now. Call in a second drummer that's going to play the lower beat. It's starting to sound like a drum pattern. And with our thirds, we should get a hi-hat. So let's call him hat. And if we run this, we should get a drum pattern. And a nice silence of 2 seconds, and then it's going to start all over again. Should we let this run to the next? No, we shouldn't.
It says we have 20 minutes left, so.
Yeah. Let's see if everybody gets crazy and runs out of here. So that was this pattern. Well, first showed a application that started up this beat. The second was playing that one, and the third was playing the hi-hats. So there's a new kid on the block, virtual threads. So if you want to use virtual threads in Quarkus, we can use @virtualThreads on any incoming methods. So a REST endpoint, a REST client, a REST endpoint is a incoming call. So you can't use @virtualThread on your repository, for example. You have to be on the receiving side, and then you can register a virtual thread. And from that point on, it will run on a virtual thread. So that's quite nice.
One thing to note is that in the beginning we selected Java 21. Otherwise, you might need to enable some preview features or something, but you need to be running on Java 21 to use this feature.
Absolutely.
From the Spring side of things, right now things are a little bit more take it or leave it, where you just enable it and set it to true, and that basically registers all your incoming endpoints to use virtual threads instead of system threads. So yeah, we don't get to choose yet per endpoint. Perhaps there's some way to do that, but I haven't found the building tutorial yet.
Maybe in the future. We never know. So, virtual threads. Who thinks the all or nothing is good or the slice and dice?
And maybe how many of you have tried using virtual threads inside their enterprise applications already? Quite a few, yeah.
Then the better question is, who is running into Java 21 in production? those same hands. A little bit more. It's nice.
All right. The next round is about the developer experience of developing on Quarkus or Spring Boot applications. One thing you might have noticed during the talk, but it's generally true for Spring Boot, is that we use these starters, and they are a little bit more batteries included. I am wondering how many of the Spring Boot people in the crowd actually look into these starters and pull out the individual dependencies that they need for their application, because that sometimes happens as well.
Oh, quite a few.
Yeah, that's quite a few. So not everybody uses these starters. It's very batteries included, but sometimes, you get security vulnerabilities on things that you're not using, so you have to go the hard way anyway.
And for Quarkus, it's just the things that you're going to use. So the REST client or the REST easy web server, Quarkus Quartz or Websockets, just specifically what you want. Nothing more, nothing less.
Then we looked into auto reloading, which is a feature that Quarkus does by default. And I thought Spring Boot could not do it, but apparently we can. You just pull in the Spring Boot dev tools, and then if you're running on IntelliJ, you do need to enable a few extra settings to make sure that your IntelliJ will build while you are just editing your code. And it's in these settings. So if you want this, make a picture of it. It is really nice. It starts up in like half a second, so you're just typing away, and when you stop typing for maybe 3 to 4 seconds, it registers that it saves the file, and then it reboots your application for you. So it's quite nice. And you can see here that, it took 0.5 seconds to restart instead of the 2.7 seconds that we had earlier. So it's nice if you're working on something, getting feedback, working on something, getting feedback again, basically.
Yeah, this is a new feature since Spring Boot 3.2,
I believe 3 or 3.2, yeah.
So that's nice. So for the Quarkus side, this is all we're going to need. It's all batteries included. And if you make a change in IntelliJ and move out of that file or out of the editor, then IntelliJ will save automatically, and that is going to pick up by the Maven plugin that we started before. And then that Maven plugin will do the auto reloading by itself. So in this case, also half a second. So it's not that much different, but they are the same applications, so kind of makes sense. If you have a huge application with tens of thousands of lines of code, this can take a while to do the hot reloading. Starting up is going to take a little bit longer, of course. But there is a way to do instrument reloading. So Quarkus will see which piece of code has been changed, and it will try to swap out only that specific part of your application, and that can dramatically reduce reload time in big applications. I don't think Spring has that one.
But not as far as I'm aware of, no.
Anyhow, dev experience. Let me see those hands. Still a lot of people or either fall asleep or are still undecided.
I think you won this round, actually. Yeah. You had quite a few Quarkus people in there. Then native images, also one of the hot features of Quarkus.
Yeah, it's also batteries included. So if you want to create a native image of your application, just run with the profile native. And if you run this, then you get a executable. And if you start this executable up, in this case, it's run in 22 milliseconds for the conductor. That's
with
nice.
The side note that you do need GraalVM for this, right?
Of course. For all native images, you need GraalVM. And that's it for me.
For Spring, we have a little bit more to configure. We need to configure some extra plugins, but we can actually do this now too, which is great. And I think also, it's kind of Quarkus inspired. So the fact that these two frameworks are competing is good for everyone. You add a few plugins, and then we also have the -p native on the build, and then we can do the same thing basically. We also need GraalVM for this, and we start up in a similar amount of time, which is close to nothing.
But still 4 times as slow. But
that's just your computer, man.
Yeah. Alrighty, native images. See, still a lot of Quarkus.
Yeah.
You're getting there. A roundup then.
All right, so everything you saw in the sheets so far, how to get started on your application. We covered REST endpoints, we covered WebSockets, both the client and server side. We covered scheduling tasks and starting up of the applications themselves. We covered the REST clients and a startup hook. So when you start up, you do something. We covered database access, virtual threads, development experience of both frameworks, and native images. I think it's time for
A bonus round.
a bonus round.
Yeah. Performance. Because in the beginning, Quarkus was really fast, and they were saying that Quarkus was X amount of times faster than Spring Boot. But it's been a few years.
Supersonic subatomic Quarkus, right?
Yeah, but it has been a few years. So Quarkus has grown bigger and more heavy. And Spring Boot is trying to lose some weight, and well,
Succeeding.
it's quite succeeding. So I ran a benchmark. And what you can see here is the end of the benchmark. And I hovered over where the first errors would occur. So I was ramping up users. And when the first errors occurred, then I would pick this. And as you can see, it's for the Quarkus side is running 551 users before the first error occurred. And for Spring, it was 546. So it's not that different. You see a little kink in the cable at the end. This is where the full GC occurs. And from that point on, it's all bad. And the same thing goes for Quarkus as well. When the full CG occurs, then you're out of it and you're lost. But performance-wise, it's not that different. And if you look up recent studies as well, it isn't that different anymore. Quarkus is winning by a margin, and that margin is usually neglectable, because if you're running a enterprise application, you'll probably be bottlenecked by your database or business logic or whatever, and not by how much traffic either Spring or Quarkus can handle. So this one is a tie. So the final verdict, why would you choose Spring Boot then or Quarkus? I would go for Quarkus if you actually have a enterprise edition of Jakarta EE already in your company or in your organization. Then moving away from example WebLogic or whatever, or JBoss, and moving to Quarkus will be a lot easier than moving into a whole new ecosystem with Spring Boot. But then again, use Spring Boot, well.
Yeah, Spring's been around for 20 years, so if you're a Spring shop, we now offer pretty much all the features that Quarkus does as well. And I really like the fact that you can get started really quickly with Spring Boot. They don't make you look for things too much. It's very batteries included. Even a monkey can do it.
Yeah, but
I'm the proof right here. That's what I meant. But
yeah, but there is also a huge history of Spring Boot, namely 20 years almost. So if you look up some answers online, you probably end up with older versions of Spring Boot. So you have to look out for that as well. Same thing goes for Quarkus. They moved with Quarkus 3 to the Jakarta namespace instead of the JavaX namespace. So if you look up older examples, then you might break stuff.
Yeah, I do have to mention, like when Spring started with Spring Security 5 and I was trying to figure out how to do some OpenID Connect stuff, I kept ending up on Spring Security 4 documentation instead, because the Spring 5 was only just out and it hadn't been hit so much yet. So there's a lot of old documentation floating around. I do think, yeah, the building documentation is very good. The Quarkus website also has nice documentation, to be honest.
Yeah.
So
if you want up-to-date documentation, go to the Quarkus website. They have documented all the things that are included in the starter applications. So it's quite nice. So with that, we thank you and hopefully gave you back some of the time that's been eaten away. If you have any questions, please come down and thank you.